Welcome back to Salesforce AI Specialist Certification Tutorial. This is the part 2 of Lesson 2, AI Fundamentals. We covered the AI concepts, including machine learning, neural networks, deep learning, generative AI, transformer architecture, large language models, in the first part. Let us continue from where we left off. We will start with the section, Customizing LLM. There are many ways you can influence the result generated by the LLM. You just saw how prompts make changes to probabilities of the tokens emitted by the LLM. Fine-tuning and RAG are other methods. Fine-tuning adapts a pre-trained model to a specific task or domain by training it further on a smaller, domain-specific dataset. As a result of the fine-tuning procedure, the weights of the original model are updated to account for the characteristics of the domain data and the task you are interested in. During fine-tuning, the model's weights are adjusted to align its outputs more closely with the desired results, leveraging its foundational knowledge. This is cost-effective than training a new model from scratch. But it still requires a lot of computing resources. Retrieval Augmented Generation, RAG, is the next one. RAG is basically modifying your prompts with context-specific data. Instead of relying solely on pre-trained knowledge, RAG models fetch relevant data from a knowledge store, such as documents or web resources, and use it to modify the prompt. For instance, a customer support chatbot using RAG can pull specific policy details from your company database to provide precise answers, enhancing reliability and user experience. RAG approach is also called grounding. Another way to change the LLM output is using inference parameters. For example, the parameter, temperature, controls randomness in text generation. Higher temperatures produce more diverse outputs, lower temperatures make results more deterministic. Another parameter is top K, which limits token choices to the top K most likely tokens during text generation. We will go over additional LLM parameters in the Model Builder lesson. Another point to remember is that large language models are pre-trained on historical data, which may be several months or even years old. To get the current data, you need to use RAG. For example, if we ask the LLM the following question, what recent breakthroughs in quantum computing were presented at the 2024 Q2 Quantum Tech Conference? The response could be, I couldn't locate specific information about the conference. Now if you ground the LLM with the conference proceedings, see the difference in the response. You can see that the model found the right answer from the documents you provided. You grounded the pre-trained knowledge of the LLM with your own data. That is how RAG enhances the model output. In summary, this lesson covered AI foundational concepts, including machine learning, neural networks, deep learning, generative AI, transformer architecture, large language models, prompts, fine-tuning, and RAG. In the machine learning section, we looked into how to create a trained model using training and test data. We also looked at various machine learning models. We looked in the evolution of generative AI. We went into detail how an LLM works, and how a prompt generate answers in LLM. In the second part of the lesson, we covered customizing LLM using fine-tuning and retrieval augmented generation, RAG. This understanding of the fundamentals of AI will help you in the remainder of the course. Good luck with your certification exam. Before we close out this lesson, an important message from SalesforceZen. The environmental impact of AI, especially generative AI, is huge. There should be awareness and advocacy for mitigating the carbon footprint caused by high energy demand for training and deployment of large language models. Companies can adopt green data centers, powered by renewable energy, use energy-efficient hardware, and promote resource sharing. As users of the technology, we should also get involved in advocating for the use of renewable energy and sustainable AI practices. Thank you for your understanding.